Hello students, welcome back to Learn 24. From this video, we are going to start our new chapter, the chemical kinetics. In this video, we are going to learn about the rate of a chemical reaction. Before that, let me tell you about what is a chemical reaction. When two or more reactants with the different properties react together to form a new substance with a new properties with a time is called the chemical reaction, right? Yes. Now we have to determine the speed of this chemical reaction or the rate of this chemical reaction. How can we determine the speed of a motor vehicle? How we can determine? It is a distance traveled in a certain period of time. It is called the speed of that vehicle, right? Yes. Likewise, we can also determine the speed of this chemical reaction by calculating the change in concentration of reactants or the products in unit time. As you have noticed, the concentration of reactant is decreasing and the concentration of product is increasing during this chemical reactions. For example, here A and B combine together to form C, right? Yes. Now, A and B is kept on decreasing and C is just increasing, right? So the product is increasing and the reactants is decreasing with the unit time. By calculating this change in concentration of reactants or products in unit time, we can determine the speed or the rate of this chemical reaction. Clear? As I have told you, the reactants will become product with a unit time, right? Yes. Now at initial time T1, let's assume the concentration of reactant is R1. Reactant is R1. At T1 time, the concentration of reactant is R1 and the concentration of product will be P1. And as the time passes to T2, the concentration of reactant is keep on decreasing and let's assume that as R2. And the concentration of product is increasing and that will be the concentration of P2. At T1 time, the concentration of reactant is R1 and the concentration of product is P1. At time T2, the concentration of reactant is R2 and the concentration of product is P2. Now we have to calculate the change in time, change in the concentration of reactants and the products. For that, it is delta T, it is the change in time. We can calculate it by T2 minus T1 will give the change in time. And delta R is the change in the concentration of reactants. It is R2 minus R1. Concentration of R2 minus R1 will give you the change in concentration of reactants. And the concentration of P2 minus concentration of P1 will give you the change in concentration of product. Clear? Yes. Now we have to calculate the rate of a chemical reaction. As I have told you, it is a change in the concentration of reactants or the products with a unit time is called the rate of a chemical reaction. Now the first one is the rate of disappearance of R. The concentration of R reactant is decreasing. So we can determine it by decreasing the concentration of reactants divided by time taken. The decrease in the concentration of R is the change in concentration of reactants, that is delta R. And time taken is the change in time, that is delta T. And as the concentration of R or the reactant is decreasing, we can indicate that by adding a negative sign over here. Clear? Yes. Now the next one is the rate of appearance of product. The product is keep on increasing, so we can determine it by increase in the concentration of product divided by time taken. As it is increasing, we can determine it by the positive value. It is delta concentration of P divided by delta T. and this equations is called the average rate of reaction. It is called the average rate of reaction, can be indicated by RAP. It is the average rate of reaction. Now we have to determine the unit of this chemical reaction. As we can see, it is the concentration divided by time, right? So we can calculate it by the unit of concentration divided by the unit of time. What is the unit of concentration? It is mole per liter, right? Mole per liter is the unit of concentration. And what will be the unit of time? It is second, right? Second. So it will be mole liter inverse second inverse. This will be the unit of rate of a chemical reaction. Just remember, it is mole liter inverse second inverse. Next, we are going to learn about the instantaneous rate of reaction. We can represent it by RINS. It is the instantaneous rate of reaction. It is the rate of a chemical reaction at a particular time period, or the rate of reaction at an instant of time is called the instantaneous rate of a reaction at an instant of time. So we have already learned about the average rate of a chemical reaction. It is minus delta concentration of R divided by delta T is equal to delta concentration of P divided by delta T, right? Yes, the decrease in concentration of reactant will be equal to increase in the concentration of product with the unit time. That was the average rate of the chemical reaction. Now, what is an instantaneous rate of a chemical reaction? It is the differential form of this average rate of a chemical reaction. At delta T tends to 0, at an instant of time, it is the same as average rate of reaction minus D concentration of R divided by dt will be equal to D concentration of P divided by dt. It is the differential form and it is called the instantaneous rate of reaction. Clear? Now, we are going to learn about the unifying rate of a reaction or the general rate of the reaction. It is the change of concentration of substance per unit time divided by its stoichiometric coefficient. What was the change in concentration of substance per unit time? It was the average rate of reaction, right? It was minus delta concentration of reactant divided by delta T equal to delta concentration of P divided by delta T. And by dividing this average rate of reaction by stoichiometric coefficient is called the general rate of a reaction. Now, what is the stoichiometric coefficient? It is the number of reacting molecules which are reacting and the number of product molecules which are formed, and that number is called the stoichiometric coefficient. Let me explain it with an example. Here I have a chemical reaction. N2 plus 3H2 will give 2NH3. There are two reactants, N2 and H2. There are one N2 molecule, so the stoichiometric coefficient of this N2 will be 1. There are three H2 molecules, so the stoichiometric coefficient of this H2 will be 3. And there are two NH3 molecules are produced, so the stoichiometric coefficient of NH3 will be 2. Clear? Yes. Now we have to determine the rate of this chemical reaction. Do you remember the average rate of reaction? Yes. Minus delta concentration of R divided by delta T is equal to delta concentration of P divided by delta T. Now, by dividing this stoichiometric coefficient in this average rate of equation will give you the general rate of the reaction. So, now replace this R and P with this reactants and the products. The first reactant is N2. So, it will be minus delta N2 divided by delta T. So, the stoichiometric coefficient here is 1. Divided by 1 is the same. So, I am writing it as minus delta N2 divided by delta T. And that will be equal to minus delta H2 divided by delta T, dividing by its stoichiometric coefficient 3. So it will become minus 1 by 3 delta H2 divided by delta T. As this N2 and H2 is decreasing, we have to add this negative sign over here. Clear? The next is the product, delta P divided by delta T. So the product here is NH3. It will become delta NH3 divided by delta T divided by its stoichiometric coefficient 2. So it will become 1 by 2 delta NH3 divided by delta T. This is how we will calculate the general rate of a chemical reaction. Clear? Now let's take a general chemical reaction where AA plus BB will give MM plus NN. Here A, B, M and N will be the stoichiometric coefficient. The rate of this chemical reaction will be minus 1 by A, it is the stoichiometric coefficient, into delta concentration of A divided by delta T, that will be equal to minus 1 by B delta concentration of B divided by delta T. Here the reactants are A and B. Since they are decreasing, we are giving this negative sign over here. Clear? Yes. Now the products M and N. 1 by M into delta concentration of M divided by delta T will be equal to 1 by N delta concentration of N divided by delta T. So this will be the general rate of this chemical reaction. Here the rate of decrease in the concentration of A will be equal to decrease in the concentration of B, and that will be equal to increase in the concentration of M, and also that will be equal to the increase in the concentration of N. So this is the general rate of a chemical reaction. So I hope you guys are clear with all those concepts, and in the next video we are going to learn about the factors which influencing the rate of a chemical reaction. So see you in the next video. Until then, bye.